Okay, in this one, we are going to be looking at our tangent function. And I'm back to doing the pi over 4s. You'll see why momentarily. We're going to have to do a little bit of work before we can do our tangent. We're still going to set up our graph the same. So let's do that before we do anything else. So starting at 0, 1, 2, 3, 4, that's pi. 1, 2, 3, 4, that's 2 pi. And then 1, 2, 3, 4, that's negative pi. 1, 2, 3, 4, that's negative 2 pi. And then 1, negative 1. All right, so your tangent, when you're looking at your unit circle, your tangent is the y coordinate over the x coordinate. So let's do that real quick. So at 0, y over x is 0 over 1. That's 0. At pi over 4, square root 2 over 2 over square root 2 over 2. That's 1. At pi over 2, 1 over 0. Ah, no. Undefined. You can't divide by 0. 3 pi over 4, square root 2 over 2 over negative square root 2 over 2, negative 1. At pi, 0 over negative 1. That's okay. You can divide 0 in the numerator. 5 pi over 4, negative square root 2 over negative square root 2 over 2 over negative square root 2 over 2, positive 1. 3 pi over 2, negative 1 over 0. Ah, no. 7 pi over 4, negative square root 2 over 2 over square root 2 over 2, negative 1. And then at 2 pi, 0 over 1, 0. Now, here's what's going to happen. At these undefined, you're going to have an asymptote. So at pi over 2, and at 3 pi over 2. Now, notice going backwards, same thing's going to happen, right? At negative pi over 2, negative 1 over 0. No, can't have it. And then also at negative 3 pi over 2. 3 pi over. Yeah, that's right. Sorry. I thought I was wrong, but I wasn't, of course. All right. Now, watch what happens when I graph my points. 0, 1. Pi over 4, 0, 0. Pi over 4, 1. Undefined. 3 pi over 4, which is here, negative 1. Pi is 0. 5 pi over 4, 1. That's the first one where we got to see the whole thing. It's going to look like this. It's going to have a little point of inflection, almost like an x cubed. And then here, same thing. That's going to be at negative 1. That's going to be at 0. So it's going to hug the asymptote, just like our rational functions did. And in between, it's going to have this little, almost like an x cubed shape. A little point of inflection there. All right, so your x-intercepts are occurring at 0 pi, 2 pi. So your x-intercepts are going to occur at your multiples of pi, positive and negative. Your y-intercept occurs at 0, 0. You have no relative or absolute maxes or mins because you've got arrows on the top and bottom of each one. This one is discontinuous. It is not continuous. My domain. Trying to think of how to best say this. So our asymptotes are undefined. pi over 2, 3 pi over 2, 5 pi over 2. So it's going to be x such that x is not equal to, let's just list them, plus or minus pi over 2, 3 pi over 2, 5 pi over 2, dot, dot, dot. There's a more precise way to do that, but again, I don't want to get into that notation. My range, on the other hand, is all real numbers, because I'm going up or down forever and ever. Okay? It's actually increasing on its entire domain, right? So it's never decreasing. I don't want to say all real numbers here because there's parts of all real numbers that aren't in the domain, so we're just going to say on the entire domain. It's always increasing. It's never constant. Positive here, 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 negative here, 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 but I don't want to get into that notation. My printer's running out of ink. Okay, symmetry. It does have rotational symmetry. If you take it and rotate it about the origin, you can't see that, it will match up, which means it's odd, which means f of negative x equals the opposite of f of x. And then our end behavior, that's a notation I don't want to get into. All right, so notice this one completes an entire cycle between negative pi over 2 and pi over 2, or pi over 2, or you could say between 0 and pi. You see that? We get an entire cycle. So our period here is pi. I just realized that says, okay. Never mind. I was going to say, this says amplitude. It's not supposed to say amplitude. Or asymptotes. The other one said amplitude. This one doesn't have an amplitude because it doesn't oscillate in the same way sine and cosine do. So the asymptotes are going to occur at those odd multiples of pi over 2. And again, that's what gives me my domain. X such that x can't be equal to those values. I need to arrange this paper for next year because I didn't ask the right things there. Okay, that is it for our tangent function. Main thing to remember about the tangent function, it's going to be undefined anytime your x value, your cosine value, is 0.